Good morning, everyone. I hope that screen is visible to everyone. Uh, so in last couple of classes, we have just finished the discussion about operator overloading and type conversion in C++. Okay, and in the last class, we have just started the basic discussion of inheritance or extending classes in C++, how we can extend classes, one class from another class in C++, or how we can use reusability concept in C++ that we have just initially started in the last class. Okay. So today I also I would like to start from the beginning again about the inheritance, and then after completion of the inheritance we will move slowly towards the function overloading or polymorphism concept, which is nothing but an extended concept of inheritance, right? So as all of you know that inheritance or extending classes, this concept is one of the important property in pipe principle of any object-oriented programming language. Pipe principle consists of three terms: polymorphism, inheritance, and encapsulation. Right, where the inheritance will play one of the vital role to achieve the flexibility, power, and extensibility of any object-oriented programming language. Okay, so what power that inheritance will give? That is the question. What power the inheritance will give to object-oriented programming language like C++? The power is, the name of the power is reusability of code. The name of the power is reusability of the code, which you can achieve by implementing or adopting the concept of inheritance or extending classes in C++. Reusability is one of the very important feature in OOPS. In any object programming language has this feature, reusability, and they have implemented this feature with the help of inheritance concept. So what is reusability? Reusability is meaning of the reusability is nothing but a concept where you are allowed to reuse your existing code again and again. As for example, suppose you have written a class and you have tested that particular class, and this can be adapted by other programmers to suit their requirement. Suppose the same class you are adopted by the other programmers to use in their programs again and again. So you don't need to define the same class again and again for the programs of the other programmers. They can directly inherit the class from your program and they can use it directly. So what is the advantage of using this reusability concept? The advantage is that it would not only save time and money, but also reduce your frustration and increase reliability. Okay, so money and time it will save. That all of you understand that we save money and time as well as the complexity of the code. Okay, as apart from this or besides this, it also reduce frustration and increase reliability of your code. So the use of a class that has been already tested, debugged, and used many times can save us the effort of developing and testing the same class again and again. So this mechanism of deriving a new class from an old class is called inheritance or extending classes. Okay. So what is inheritance? Inheritance is a mechanism or a technique or a process, what I will say, that each and every object programming language adopted, like C++, whose main job is to inherit the property of one class from another class. Inherit the property of one class from another class. That means we don't need to, we actually inherit the task or responsibility of one class or the code of one class into another class. So we don't need to define or declare that same code again and again for the inherit classes. It will automatically come during the inheritance of that class. So the class which is whose feature is inherited, that class is called the base class or the child class. or the parent class. Okay, and the class who actually inherit the properties from the base class or the parent class is called derived class or subclass or child class. So inheritance class has different kind of names. Okay, the topmost, the uppermost class which actually inherited, whose property is inherited by some other class, that class is called superclass or parent class or base class. Remember all these terms, because in examination they can use any terms while they are giving questions, or in interview they can use any term. Okay, and the class which will inherit the property of the base class or parent class or superclass, that class is called subclass or child class or derived class. So whenever you are using this, we actually use the pair of these terms. Like while you are using base class, we'll have to use a derived class. While you are using parent class, we'll have to use a child class. While you are using super class, we'll have to use the subclass. Okay. So in the last class, I have given one example, a real life example to represent inheritance property, the example of a bird class. If you remember, this class example I have given to you, to everyone. So a bird class has, is the parent class. We can consider a bird class as a parent class, right? So this bird class has these properties or features which will be represented in terms of its members, right? So this bird class has two kind of members, member variables or data members. One is number of wings, that is equal to 2, and another one is number of legs, that is also equal to 2. And it has one kind of member methods or member function, that is it. Okay, so I have told, if you remember in the last class, I have told that your parent class should contain those members which will be common to its child classes. It cannot or it should not contain any unique member that is unique for its own class. Okay, parent class must contain those members which will be common for all of its child classes. So what are the child classes of the bird class here? Bird class is considered as a parent class and it has 3 child classes. We will consider it as a 3 child classes: sparrow, penguin, and ostrich. Right? All are part of the bird class. I think all of you know that. These are called child classes. Okay. Now, all the sparrows has this common 3 properties. All of you agree with it, that all the sparrows must have wings, must have legs, and must have a eat function. But to live, sparrow must eat something. Okay. In the similar way, penguin also has these 3 members of the bird parent class, and ostrich also has these 3 members of the bird parent class. But there is one important thing, is that the child class which inherit the properties of its parent class, they can have some properties which can be unique of its own class. They can have some properties which can be unique of its own class. Like sparrow can fly. So fly is a unique property of sparrow. In the similar way, penguin can swim. Penguin cannot fly, it can swim. So it is a unique property of the penguin class. In the similar way, ostrich cannot fly, cannot swim even, but it can run. So run is a unique property of the ostrich class. So along with all this property of the parent class, these 3 child classes holds its unique and common properties. So one thing is important. Another thing, I have drawn one more class by inherit the properties of its previous 3 classes: sparrow, penguin, and ostrich. That crow class that I'm considering, right? So logically it may be incorrect. Okay, that crow can fly, crow can swim, crow can run, but we will consider it that crow is such kind of bird which can do all the properties or members of its parent classes. So who are the parent classes of the crow class? Who are the parent classes of crow class?
Bird.
No.
Base.
Bird is actually grandparent for the crow class.
Child class. Sparrow, penguin, and ostrich.
Yes. So the immediate classes are called parent classes, and then the previous classes are grandparent, the grand to grandparent, whatever you name you will give. Okay, so immediate classes, immediate inherited classes of the crow class are sparrow, penguin, and ostrich. Okay, so it will inherit all the properties of these immediate three parent classes, and this is the grandparent class of the crow. So obviously, when the crow class inherit the property of these classes, automatically this property came into the crow class, right? So crow class is a grandchild class compared to bird class, and is a child class compared to sparrow, penguin, and ostrich classes. So this is the overall real life example where you can implement or apply inheritance kind of concept. So if you remember this flow chart, I guaranteed you that you never forget what is inheritance. If you remember this real life example, you will never forget, right? Now, the second thing that I need to tell you, what are the types of inheritance? That is very important. Various kind or various types of inheritance. The first type of inheritance is called single inheritance. It's called single inheritance. The first type of inheritance is called single inheritance. Now, what is single inheritance? Listen very carefully. What is single inheritance? A derived class has only one base class. That is called single inheritance. So let me show the PPT. Obviously, it should define inside the PPT. Some other kind of examples are showing in this hierarchy. You can use that example. Okay. So type of inheritance, it will start with multiple, but I should start with a single, but I don't know whether it is not given here. Okay, no issue. So we should start from here. Single inheritance. What is single inheritance? Single inheritance must have one base class, followed by one derived class. That is single inheritance. It has only one base class and one derived class, or you can say only one parent class and one child class. That is called single inheritance. So in this diagram, can anyone tell me where we have applied the single inheritance, or where we can apply or implement the single inheritance in this diagram?
Birds to sparrow.
Only birds to sparrow?
No, all of these, penguin, ostrich. Right.
Oh, yes. So in all these cases, if we consider individual cases, then we can apply the inheritance. So first case, bird to sparrow, we can apply first single inheritance. Then in the next case, bird to penguin, we can apply second single inheritance. Then bird to ostrich, another single inheritance. Then from ostrich to crow, another single inheritance. Penguin to crow, another single inheritance, and sparrow to crow, another single inheritance. So if we divide this entire diagram into individual inheritance, then it is called a single inheritance. I think concept is clear to everyone. Is it clear? Anyone has any doubt?
Hello, sir. Sir, can you repeat this? I lost my connection.
Okay. The first type of inheritance is single inheritance. Single inheritance means an inheritance which has only one base class and one derived class. An inheritance which has only one parent class and one child class. That is called single inheritance. Okay. So in this diagram, where we can implement the single inheritance, in each and every cases, if we divide this diagram into individual inheritance, then we will implement the single inheritance in each and every cases. Like bird to sparrow, one inheritance. Bird to penguin, another inheritance, single inheritance. Bird to ostrich, another single inheritance. Ostrich to crow, another single inheritance. Penguin to crow, another single inheritance, and sparrow to crow is another single inheritance. So in each and every cases, we can implement a single inheritance in this diagram. Okay, is it clear to everyone? Conceptually,
Yes,
it is clear to everyone? Okay, very good. Now the second kind of inheritance is called multiple inheritance. Inheritance. Let me first define you the definition. What is multiple inheritance? Multiple inheritance has more than one base class and only one derived class. Let me repeat again. In multiple inheritance, it has more than one base class and only one derived class. So multiple inheritance will be looking like this. Base class, okay, base class, and it has derived classes. So it will look like this. Base class 1, base class 2, okay, and it has derived classes. This one and this one, okay, and only one derived class. That is your multiple inheritance.
Like
Understood?
pro.
Yes. So here, where the multiple inheritance exists in this diagram, more than one. Okay, more than one base class. Please remember this thing. This should be dot 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 means it can have n number of base classes. It can have n number of base classes, but minimum base classes must be 2. Minimum base class must be 2. Obviously must be 2 because otherwise it will be converted to single inheritance. It cannot be multiple inheritance. Okay. So in this diagram, where we can implement multiple inheritance?
No.
In this diagram, we can implement multiple inheritance from this part, in this part. Look my cursor in this part. Okay. In this part, we can implement multiple inheritance. Where sparrow, penguin, and ostrich. There are 3 base classes which will be inherited by a single derived class, that is crow. Or more than one parent class which will be inherited by a single child class, that is crow. So crow has a property of all its base classes or parent classes together. Clear? Everyone clear? Any doubt, anyone? Is it clear to everyone? Tell
Yes,
me.
sir. Yes, sir. Yes, sir.
Okay, very good. Now the second kind of, third kind of inheritance is hierarchical inheritance. So all of you have some idea about the hierarchy. Hierarchy means the structure of a hierarchy is just like an inverted tree. Okay, a structure of hierarchy is just like an inverted tree. That means the root of the tree should be at the top, and then there are several leaves or branches are there. So in data structure, while you will learn that chapter of binary trees or tree data structure, you will learn the nonlinear data structure. Tree is a nonlinear data structure where you will learn the hierarchical concept. Okay, so hierarchy inheritance is just opposite of this multiple inheritance. Hierarchical inheritance is just opposite of this multiple inheritance. How? Let me draw. So there is only one base class in hierarchical inheritance, only one base class, and there can be multiple derived classes, at least 2 derived class or more than 2 derived class.
Like Bart class to Sparrow, Penguin, Ostrich class.
Yes, there's a derived class 1, derived 1, okay. Then this is derive 2, okay. Then this is derive 3, and so on, okay. Dot 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 means so on. So there is only one base class and multiple derived classes. So in this diagram, where we can apply the hierarchical inheritance, one base class, multiple derived class.
All diagram. Bird to sparrow, penguin, ostrich.
Yes. So in this space we will apply it. So bird to sparrow, bird to penguin, and bird to ostrich. Here we can apply multiple inheritance. Okay. So here multiple derived classes fits the property of the common bird class. Here, fourth kind of inheritance, multi level inheritance. Multi-level inheritance. What is a multi-level inheritance? Very simple. Suppose there are base class 1, okay, which will inherited by a derived class that will be again inherited by another derived class. That is again inherited by some another derived class. This is called a multi-level inheritance. So there is a concept of a child, a parent, a grandparent. This kind of concept exists here. So base class, which will be derived by derived class, which will be derived by another derived class. So you can numbering this thing as like this, and this should be a dot dot. That means this should go for n number of times. Okay, this can go for n number of times, right? That is a multi-level inheritance. So in this diagram, where you can apply multi-level inheritance?
Bird to penguin to crow.
Yes. So there are 3 multi-level inheritance we can apply in this diagram, where bird to sparrow to crow, this is multi-level. So in this case, crow is a child class, this is a parent class, and this is a grandparent class. So this is a multi-level inheritance first. Second multi-level inheritance, bird to penguin to crow. The same concept. Crow is a child, penguin is a parent, bird is a grandparent. Then third multi-level inheritance, bird to ostrich to crow. So 3 kind of multi-level inheritance we can apply in this diagram or in this real life example. And the last kind of or last type of inheritance is called hybrid inheritance. So I think you can understood what is hybrid inheritance, where all these 4 kind of inheritance can be implemented together. It is called hybrid inheritance. That means within the hybrid inheritance, there must be a single inheritance, there must be a multi-level inheritance, there must exist hierarchical inheritance, there must exist multiple inheritance. That is called a hybrid inheritance. So in this diagram, where you can implement hybrid inheritance?
All diagram.
All. So this entire diagram is representing the hybrid inheritance, the entire diagram. When you are going to implement these entire classes, okay, by implementing a single, multi-level, and multiple, and hierarchical together, then it is called hybrid inheritance. So the entire diagram will represent the hybrid inheritance. So is it clear to everyone? Tell me. Is this concept clear to everyone? In Java, this multiple inheritance cannot be implemented directly. Just remember this line. You don't need to remember more than this. Java cannot implement multiple inheritance directly. Only this one, multiple inheritance. Rest of the inheritance Java can implement directly, but multiple inheritance Java cannot implement directly. Java can implement multiple inheritance with the help of some kind of concept called interface. Okay, but in C++, there is no issue to implement multiple inheritance directly. C++ can implement multiple inheritance directly, all the inheritance directly. Okay, you just remember this statement, nothing else regarding Java, because sometimes the interviewer will ask this question that what is the difference between Java and C++ in terms of multiple inheritance? Then you have to answer in such a way. Okay, while you will learning the Java in the next semester, your conception will be clear. Okay, then you can match with the concept of C++. So is it clear to everyone? Tell me, give me a response. Is it clear to everyone? All types of inheritance.
Yes, sir. Yes, sir.
Anyone has any question, any doubt? This is very important. This question will come frequently in the examination. Okay, so let's start with the coding. Okay, First, what we are going to implement first and simple most. Today we are going to discuss about the implementation of single inheritance and its various issues. Implementation of the single inheritance in C++ code and its various issues that we are going to learn today. Okay. Then from tomorrow, then we will do the other kind of inheritance. Okay. So this is the single inheritance. Okay. So here I have implemented in terms of A and B class. So you can implement this example as well. In the lab, I will give this example to implement you. Okay. In the lab, you will practice this example. Right. But here I am going to show you the implementation of single inheritance in the general form of A and B class. Right. Try to understand the program very, very carefully. Minutely. Class A is the first definition of this class. Right. Class A. In this class, these are the members of the class. With the help of encapsulation, we can bind all these members into this class, class A. Clear? So class A will be considered as a base class or parent class, whatever you say in this program. Right? So this is a private member by default, and all these are public members. So within private, there is only one variable, and within public, there is one data variable and one member method. Clear? Up to this, everyone clear, I think. Now, there is one more class, class B, which is called a base class. So here, class B inherits the property of class A. That means implement the feature of reusability. Reusability of code. Reusability of code means while it inherits the property of class A into class B, that means automatically all these variables are inherited inside this class B. We couldn't say it. That is virtually inherit. But while you are accessing class B, you are also eligible to access the members of class A, because class B inherits class A. How it can inherit syntactically? It will inherit with the help of this single colon. Syntactically. The class B inherits class A with the help of this single colon. And we'll have to use, here I have used public keyword. That is important. Why? If we use public keyword, what will happen? If we use private keyword here, what will happen? That we will discuss. Okay. So this is a public keyword we will use here to inherit class A properties into class B. What are the properties of class A? These are the properties of class A. Now, what are the properties of class B? These are the properties of class B. So class B will declare a C variable as private, and within public it will declare a variable F and do the factorial operation, a simple factorial operation. All of you are aware with the factorial operation. That is the job of class B. So now, while you will write this line, automatically you have called the inheritance and you have called the reusability of code concept. That means all the properties of class A is now available within class B virtually, along with the unique properties or own property of class B. Right. Now your question said, I will have to access all the members of class A and class B. So till now, if we want to access all the members of class A and class B, what will be our approach? Our approach in main method, we'll have to create the object of class A and we'll have to create the object of class B individually. And then by the help of that object dot operation, we are going to access the members of class A and class B respectively. I think it is clear to everyone till now, because this kind of thing we have already done multiple times to access the members of multiple classes by using objects, creating objects of different classes. Here, where you have implemented the inherit property, here in the main method, you don't need to create individual objects. You have to create the object of the base class or the child class. Which one is the child class here, or base? Object of the derived class or the child class? So
Class
which one
B.
is the child class here? Class B. So we will need to create the object of class B. Now, can anyone tell me why we are not creating the object of class A? Why we are preferred to create the object of class B?
Because by class B we can access the variable of class A.
Yes. Very good. Because class B has already inherited class A, so it has already implement all the features or the members of class A inside of class B itself. But it has been implemented virtually. You cannot say it here, but it has been implemented virtually. So while you are creating the object of class B, the object of class B is so much powerful that it can access the member of class B as well as the members of class A due to this inheritance concept. So the same thing we have done here. We are creating the object OB of class B. Okay. Now, by the help of class B OB object, we are able to access the variables OB.P, get value, fact. So get value and P variable is the variable of which class? A class. And fact is a member of which class? P class. Clear? Everyone clear? Tell me.
Yes, sir.
Yes, sir. Yes, sir.
Very good. We will run it. So class A variable is accessing correctly. This is the class A method correctly, and this is the class B method. So class B object is so much powerful that it can access all the members of its own class as well as its parent class. That is the concept of reusability of code or inheritance from one class to another. So it is a single inheritance. You can only identify these things because these are base class, one base class and one derived class. So it's a single inheritance. I think all of you agree with me. Now the thing is that if we are going to access this one, C variable. So let's check out C variable is a part of which class? B class. And it is a private variable of B class. So if you want to access it, it will give error. Why? Why it will give error?
Because
So private data members cannot be
You
inherited.
cannot access private members.
Yes, very good. That all of you already know it because C is a private data member of class B. So if we try to access the private data member of class A, that is val, can we access it? Let's check it out. So we again cannot access it. So from here we can conclude that private data member cannot be inherited. Private data members cannot be inherited. Now the question came to your mind, sir, if private data member cannot be inherited, then how we can access private data member? Obviously, we have defined some member as a private, so there must be some way to access it. Otherwise, we have to define it as a public. Obviously, there is a way, and that's why you also know it. Let's take it out. Go to the next program to check. Here how we can access a private variable. We can access the private variable by the help of its public member function. Look, this one. We have already done it. We can access this private variable by the help of its public member function that we already know in the previous classes. I have already shown how we can access a private member through a public function. The same logic is applicable here. So val is a private variable in class A that we have accessed with the public function get value of this class A. Right? So here we will get the output 10. This is the output of a private variable of class A. Now in the similar way, if you want to access this C, how we can access? With the help of this public function of class B. The public function of class B is what? Which one? Fact. So we can do, simply we can print C here, but C doesn't have any value. C variable of class B is, okay. So it will be easily understood, the concept of C variable. So here we have given some value of the C variable, suppose 50. Okay. So is it clear to everyone how we can access private variable?
Yes, sir.
Is it clear to everyone?
yes, sir. Yes, sir.
What about others?
Yes, sir.
Okay. Very good. Very good. Now, this is a inside class definition. You can also do the outside class definition. It's your choice. If you want to do an outside class definition, you can do it. You can go for it. Like you can do this thing, which we have already done. Avoid a colon, then get value. You can do these things. It's your choice. It is also allowed.
So return type of get value is not void, it is in. So
No, I didn't do any return type here. That's why I'm using void. Okay. Actually, we can use void here. It means int I have given, but I didn't return anything. I forget to, but I just mistakenly give that int specification. Okay, you don't need to do that.
yes, sir.
But declaration should be done. Okay, declaration should be done. Void get value in such a way. Okay, the declaration has been done and external definition of this one. Clear? Is it clear to everyone?
Yes, sir.
So this is a implementation of the single inheritance. The last thing that I need to tell you that how we can implement a single inheritance with a private class. That means instead of calling this A class along with the public access specifier, if you call this A class with the private access specifier, then how it will work. So that means this class B is a public class. Try to understand. This class B is a public class, and we call the base class or its parent class, which is private in nature. That means all its member is automatically private, converted to private, right? Now, how we can access this one? So if you want to access the member, this get value member of this private class A, then you will have to pass this get value member through the public function of class B. What I have said, if you want to access the private member method get value of class A, which is private, the entire class is private while you are inheriting it. So you can access the private member function get value by passing this get value function through a public member function of class B. So here the public member function of class B I have defined as a display. You have seen it. This is the old function which we have already used. This is a display function which I have defined extra in this class B. And within this display function, we have passed the private function of class A, that is get value, whose definition has been already given here. So we can run our code successfully by doing this. Understood? So you cannot directly do these things, ob.getValue. If you do these things like the previous program, it will give error. Why? Because you have inherited the class A as a private member, private access specifier. Clear? Do you understand? Tell me.
Yes, sir.
What about the others? Is it clear to everyone? How we can access?
Yes, sir.
So I'm repeating again the private member function of class A, which you have converted into a private during the inherit call. You can access those member functions with the help of public member function of the base of the derived class. Public member function of the derived class. So which one is the derived class? Class B. Which one is the public member function of the derived class? Display. And within display, this get value function will be passed to access it. Okay. So I will